We are looking at the scientific method Plop, Plop, Fizz, Fizz lab. So the question is, will Alka-Seltzer tablets dissolve faster in different types of water? I don't know. What do we think? So the independent variable is what we're going to be changing, and what we're changing is these different types of water. Okay? Then our dependent variable is, now that I changed my different types of water, what am I going to measure? Well, I want to measure how quickly my Alka-Seltzer tablet dissolves. Okay, so the amount of time for the Alka-Seltzer to dissolve. Now, controlled variables, they're the ones that need to stay the same. And there's a lot of things that we could keep the same. However, these need to be things that if I did change them would give me different results. So the two things that I'm going to keep the same are I'm going to use the same volume of liquid, and I'm going to use the same size tablet each time. Okay, then we have a question. Of the variables above, which one is going to serve as our control group? So here's the variables above. We want to know which one of these is going to show us what does Alka-Seltzer do normally. Well, that is going to be our tap water. So we're going to use tap water as a control to show us how quickly does Alka-Seltzer normally dissolve in a cup of water. And that's going to help us to see if our answer is any faster or slower. Okay? So then we need to develop a hypothesis. If I use this type of water, then I think this is going to happen. And I'm going to pick a popular one with my students. Okay, so this one is popular with some students. So if I use the acidic water, then the Alka-Seltzer will dissolve faster because of the acid in the water. So now we need to design our experiment. Are we going to use a whole tablet or a half a tablet? Well, we're going to use a whole tablet. And we are going to measure how quickly it dissolves with a timer. And we're going to place 200 milliliters in each of our beakers. Okay, then will the amount of liquid, we're going to change water to liquid, be the same in all of our tests? Yes, it's going to be the same, 200 milliliters. And the safety precautions we're going to take are going to be safety goggles, a lab apron, and gloves. Even though this stuff is not super dangerous, we're going to pretend that it is so that when we're in higher science classes, we're already familiar with proper safety techniques. Okay? All right, now on our data table, what we're going to do is we're going to put our independent variable here and our dependent variable there. Okay, so we have our water type. Our independent variable was our water type, and these are the 5 types that we have. We have tap, our controlled, then acidic, salty, hot, and cold water. And our time is going to be in seconds. Now, since I put the S here for seconds, I don't have to attach that unit here to my numbers because we already know, hey, all of these numbers are going to be in seconds. So let's do this experiment and get some numbers. Recording? All right. So this is our tap water, our controlled. Here's the Alka-Seltzer tablet. In 3, 2, 1, drop. So you can see the bubbles. These bubbles are an indicator that a gas is being produced. Anytime we have a gas being produced, which gives us the bubbles, we know that there's some kind of chemical change going on. That's one of our indicators, which we're going to learn about later on in the year. So you can still see the tablet is floating now at the top. It's almost gone, but not quite. A little bit more. And gone. Okay.
Yep.
Okay, so
Wait.
now we're going to do our acidic water. So it's a 50% vinegar, 50% water. And we got our Alka-Seltzer tablet. 3, 2, 1, go. So this one looks like the reaction is happening faster, and as you can see, the whole solution is really cloudy. It's going to be really difficult to see where exactly that tablet is, so we're going to have to be paying attention to where the bubbles are coming up.
Yep.
Still see it in the middle. There's still a lot of bubbles coming from exactly the middle, really big ones, saying that the tablet is still there. Alright, so we're going to stop it. You ready?
Yeah.
Alright, so now we have our salt water. I tried to put as much salt in here and stir it up to where it was all dissolved and there was none sitting on the bottom. 3, 2, 1, go. Got a little splash on that one. Alright. So if you notice, this one definitely looks slower than our acidic water. And maybe even a little bit slower than our controlled. And there's some stuff just like on the top. Little pieces of the tablet that are not just, they're just not going to combine with the water because there's salt in there. Alright.
Wait, say that again.
33.16.
Alright.
Don't record yet because I have to. Okay, so here's our hot water. You can see that it is really hot. It's at about 200 degrees Fahrenheit. 3, 2, 1, go. Wow, that is really fast. You can still see there's vapors coming up because it's so hot. You can definitely smell it. All right. Go. Pause it. Oh, we're at 20.80. All right, so the last one is our cold water. It's been in the fridge, but we still have 200 milliliters. Or 200 milliliters. 3, 2, 1, go. Well, that's very slow. This might take a while.
It's still recording.
Alright, so sometimes the tab goes up a little bit, and that's because we're having air bubbles that are underneath it, pushing it up. Eric is awesome.
I didn't record it when they said air.
Okay. Then you don't know who Eric is. Don't worry about it. So we still have a tablet in the back. I'll turn it so you guys can see it. Well, I'll pick it up and turn it. Otherwise, it's just going to follow me.
Just like...
For every action, right? There's an equal and opposite reaction. Oh, so it's at the top. We're almost done now. This water was really cold because it's taking a very long time. All right, we are at 1 minute and 7.21 seconds. But we're going to put that in all in seconds, so check. Okay, so here were the results from our test. The tap water was at 35.93 seconds. The acidic water, 36.45 seconds. The salt water, 33.16 seconds. The hot water, 20.8 seconds. And the cold water, the slowest, at 67.21 seconds. So you can see how they compare to our control. Only the salt water and the hot water were faster. So it's very interesting. So now we need to make our graph. So we're going to have, on the y-axis, we're going to have time in seconds. Again, you got to put the S in the parentheses so we know what units these numbers are talking about. And we're going to start at 20.5 because our lowest number is 20.8. So we have to be a little bit lower than that. And then we're going to go up by threes all the way to 77.5, which gives us plenty of space for all of our data. Now on the bottom, you could do each of these little grid parts as one of your bars for the bar graph, but that is very squished and it's very difficult to look at. So what you want to do is you want to try and use the whole x-axis that you are given with what your independent variable is. Okay, so we're going to skip that first one, and then we're going to make each of them 3 rectangles wide. And then skip another one, 3. Skip, 3, skip, 3, skip, 3. So now try and draw your bars and check back later. Alright, so here's my graph. You're going to want to make it look nice and interesting. If you don't want to color them all in solid like that, these are just some different options to make it easier to look at the bar and not just leaving it blank. So the tap water, which was at 35.93, should be just above that 35.5. I mean, it's going to be a little difficult to get a very exact number because we're going up by 3, but you want to be as close as possible. Then our acidic water was at 36.45, so it's going to be a little bit taller than tap water. That's the important part for us. Salt water at 33.16, you can see it's above 32 and it's below 35, and it's not quite in the middle, just a little under. Hot water, the fastest at 20.8, is just barely over that 20.5 mark. And cold was our slowest at 67.21. And so it's above the 65 line and not at the 68 line. All right, and now we are going to talk about more why there was such a difference here and molecular movement. So stay tuned for that in class on Monday.